In this video, we are going to learn to determine order of reaction. We will see the third and fourth method, half-life and linear graph method. Half-life equation method is used when the half-life for a corresponding initial concentration of reactant is known. If you plot a graph of concentration of reactant against time and produce a straight line, it is a confirmation that the reaction is zero order. So, you don't need to make further investigation. However, if a curve is produced, we need to make extra steps. We have to determine the half-life for the reaction by determining the time taken for the concentration to reduce to half of its initial value. Next, we have to determine the second half-life by determining the time taken for the concentration to reduce to half of the amount after the first half-life. Then, we have to compare the half-life. If the first half-life is equal to the second half-life, this means that the reaction is first order. But if the second half-life is twice as the first half-life, this means that the reaction is second order. Example, there is an arrow in this question. The question marks is actually an arrow. The following results were obtained from an experimental investigation on dissociation of the nitrogen pentoxide at 45 degrees Celsius. Plot a graph of concentration N2O5 versus time and determine the order of the reaction and the rate constant. So, first we have to plot a graph. By looking at the plotted graph, we can see that a curve is produced. This means that this is not a zero order reaction. We need to find the half-life. The first half-life is when the initial amount of 176 times 10 to the power of negative 4 is reduced to half, which is 88 times 10 to the power of negative 4. The time taken is 20 minutes. Next, we find the second half-life when 88 times 10 to the power of negative 4 is reduced to half, which is 44 times 10 to the power of negative 4. The time taken is also 20 minutes. Based on the above graph, the time taken for the first half-life is 20 minutes and the time taken for the second half-life is also 20 minutes. This means that the first half-life is equal to the second half-life. So, this reaction is first order. Next, we have to find the rate constant. Since this is a first order reaction, we can just use the first order formula for half-life. And we will get the rate constant is 0.03 per minute. The last method is rate law method. It is used when the reactant concentrations at several time intervals are known. The determination may be done mathematically or graphically. Mathematical determination of order of reaction involves calculation of the rate constant K using all the rate law starting with the zero order rate law until a constant value of k is obtained. Graphical determination of order of ration involves plotting graphs using all the rate law until a linear graph is obtained. We will focus on the graphical determination. If the ration is zero order, a linear graph is obtained if you plot a graph of concentration against time. The gradient of the slope will be the rate constant of the ration. If the ration is first order, a linear graph is obtained if you plot a graph of ln concentration of reactant against time. And again, if you find the slope of the graph, it is equal to the rate constant. Last but not least, if the ration is second order, the graph of 1 over concentration of reactant versus time will produce a straight line. And this time, the slope of the graph is equal to the value of k, which is the rate constant. That's all. Thank you.